Hello, yes, I'm Darren from Manchester, not Sheffield. Not that there's anything wrong with Sheffield, of course. You know, it's a lovely place, so I've heard. Yeah, I'm going to be talking about image performance. So a little bit about me. I'm a freelance front-end developer based in Manchester, and I've been lucky enough to work on quite a lot of large sites. So if you've been to any of these sites, you've probably seen some of the front-end work that I've done. Apologies about Southern, I have no, nothing to do with the train service, but the website's great. So image performance and why you should care. I'm going to be talking specifically about raster images as opposed to SVGs. So it's mainly kind of the big ticket items that I'm going to be looking at. So according to HTTP Archive, currently images make up about 62% of page weight, excluding video. We're just going to conveniently ignore that because that loads in later, that's fine. There's an average of about 970 kilobytes of images per page, and that's split across 31 image requests. So it's kind of a huge amount of requests and size in terms of file size. And it's not getting better, as Andy said. If we look at the graph for the past 3 and a bit years, image size just keeps getting bigger and bigger compared to the rest of the size of the stuff on the web. JavaScript, funnily enough, keeping pretty consistent, but still getting bigger as well. So to increase the performance of images, we'll make the download faster by reducing the amount of data that people use, which is also going to cost users less if they're paying for the data, if they're on a mobile plan or something like that. We're going to use less power, less time that you spend on Wi-Fi or a data connection. It will save on the power that the device is using. If they're on a mobile device, that's quite important as well. And it makes people happy. They might not know it, but the faster a website is, the happier they will be. So, getting started, you should all be familiar with the bog standard image element. Old as time. What we can do is we can progressively enhance that using the source set attribute. And what that does is allows you to specify a number of different images and the widths of those images in terms of the files themselves. So here we've got 3 different images. We've got small, medium, and large, and the sizes are next to them, which is denoted by the W, the width attribute. So instead of 320 pixels, you do 320 W. What we can also do is specify a sizes attribute. And what that does is it uses the media query, and then it tells the browser how much space that image is going to take up at that particular breakpoint. So here at 20 EMs, we're telling the browser that that image is going to be the full width of the page. And then we tell it at 40 EMs, it's going to be 3/4, and then half the width of the page down. So all this is doing is giving the browser an idea of how big the image is in terms of its file size, and then how big it's going to be displayed on the screen. And that allows the browser to choose which image it's going to show to the user. So it might choose the medium image as the best case out of all the options that it's got. We've also got the picture element, which is a new element for HTML5, and it includes source element as well. So a picture can have multiple sources. Sources contain source sets, and they can also contain the size attribute as well, the same as the image can be used with. What we're doing here is we're using the pixel density identifier, which is an X instead of a W, and you can have 1, 2, 3, upwards as many as you like to target different pixel densities, which we'll go into in a little bit. What we've also got is the media attribute, and now this is a hard and fast rule for the browser that says this source will be used at this particular breakpoint. So here we've got the, at the bottom we've got the image file, which is the fallback, but it's also the first image that will get loaded. When you hit 20 EMs, you will get the small image, 40 medium, 60 large. So here you're actually telling the browser, use these images at these particular breakpoints. You're not letting the browser choose for itself which one it wants to use. And what we're saying is for a pixel density of 1, use the first image, and for a high density display, use the second one, which is going to be a larger image. Any browsers that don't understand picture or source we'll get this image here as the fallback. So which solution is the best one for you? And it really does depend, because source set and sizes is a great kind of quick, easy solution to use. You don't have to specify much at all. You can just specify source set. You don't have to do sizes. And then the browser will just look at the different sources that you do, and it will decide which one to use for you. So it's a great one to just bosh in there and let the browser sort the rest out. With picture, you've got the source set and sizes that you can use, but you also can use the media query to force the browser to use a particular image. So you've got complete control over which image is being used. And I'm a bit of a control freak, and I do like to tell the browser which image to use at different places. So I tend to use the picture element. In terms of browser support, they're both supported exactly the same. It's everything except IE and Opera Mini. So you can choose to either let the fallback be the image tag within them or the image source, or you can use like a JavaScript fallback for that as well. So we've got our solutions for putting the image in there. Which format image are we going to use? So there's different types of formats that we've got. We've got lossless and lossy. So a lossy image is one that will degrade as you compress it. You'll lose that quality and you'll never get it back. A lossless one, it will retain the original image quality. Then you've got images that can have transparency and images that can have animation. So for example, a JPEG is a lossy. When you save that out as 20%, you can see the artifacts and all the degradation. For GIFs, they're also lossy, just 256 colors, but they have an alpha channel and they can be animated as well. Obviously, everyone's seen animated GIFs. PNGs, lossless, so really good quality images. They've got the transparency, and they can be animated as well, but because of the file size that comes out of them, you don't really want to use them as a format on the web. PNG 8 was created to replace the GIF. Don't know if anybody remembers the kind of the copyright problems that there were with the GIFs back in the early noughties, but it was created because of that, and it also reduces some of the file size compared to a GIF, but does exactly the same thing. Now, WEBP is the new exciting format on the block, created by Google, and it's kind of really well supported at the moment in terms of browsers. It can be lossless or lossy, depending on which compression algorithm you use in it, and it can also have transparency and animation. So it's the kind of the one solution that fits all. So we're going to look at WebP and just do a quick comparison test in terms of compression versus JPEG, which is kind of the most ubiquitous kind of image format on the web at the minute. So compressing the JPEG with Photoshop. WebP, we're going to do it via the CLI, the CWebP tool created by Google, which you can download. Links are all in the slides, and I'm going to give you the link to the slides afterwards as well. So we're just using a 1500 by 2000 pixel image here as a test, and it starts off as a 4.7 megabyte PNG, which is ridiculous. And it's me. It's very meta because it's a unicorn on a unicorn. So, so if we look at the compression results for a JPEG, we start off at 100%, 1500 by 2000 pixels, at just under 2.25 meg. And it goes down all the way down to about 60K, I think, at the end. WebP, we start off at 100% at just over 1.1 meg, and then it goes down to about 25% better quality than a JPEG at the end. So WebP is normally a lot smaller than JPEGs. So it's definitely worth looking at if you can output your images in WebP format as well. So in terms of browser support, it's not perfect. Don't cry, it's fine, it's fine. So IE is obviously out the window anyway. You can fall back however you like with that. If you need to support it, I'm going to show you a way. But obviously Safari is the big killer because it's lagging behind in terms of WebP support. But if we look back to picture support, we can see that that solves the Safari issue. It's never going to solve the IE issue, but we're just going to conveniently ignore that, so that's fine. What we can do is we can use the picture element to create a fallback image system. So what we'll do is we have the type attribute. So we have our WEBP image, and you can do this with all the same source set stuff as before. So you can have your multiple sources, densities, and everything. And you specify the type as image/WebP. And then you also have the same thing, but with your JPEG. Now, if the browser understands the source type of image/WebP, it will use that one. If it doesn't understand that, it falls back to the JPEG. So with this method, we can make sure that the user, if they understand WebP and can display it, will download that one rather than the JPEG. So that's kind of the best case option for us, really. And then, i.e., people can still get the image. Pixel density. So we've touched on that. It's basically the concept of how a physical pixel is rendered with CSS. So older devices, 1 pixel on the CSS is the same as 1 pixel on the hardware. Things like iPhones with the Retina displays, they use 2 pixels in each direction to render 1 pixel. And we go upwards 3, 4, 5, however many crazy pixels you need. So for our little icon here that's displayed at 50 pixels across, on a 1x display, you get 50 pixels by 50 pixels, and that's how it's rendered. It's never going to show any different to that. For a Retina display, to show this same image as crisply and as clearly as the display can show it, you're going to have to make it 100 pixels wide. Otherwise, you're going to see pixelation in it because the browser will scale it up to fill those physical pixels. And then you've got the same again for higher resolution images. And what you see is obviously as the size of the image increases, so does the file size as well. And this is where we start getting really huge images for websites that are catering for these high resolution displays. So different devices have different pixel densities. Tends to be that the older, cheaper, or larger devices have the lower pixel densities. So things like old phones, old laptops, or TVs. And then the newer, more expensive devices, or the smaller ones, tend to have the higher pixel density ratios. So modern phones and things. And browsers will up and down scale images depending on what they need to do for the device that they've got. So if you've got a 100 pixel image and it's in a 50 pixel wide CSS width, the browser will downscale that depending on which case it is. And obviously, larger density equals larger image, which equals larger file size, which is where we get the performance issues. So the idea is that we don't give the user any more pixels than they actually need. So the same with WebP over JPEG. If we can get them less pixels, do it there. And it's the same with pixel density as well. If we can serve a 2x image only to people who have the high resolution display, then we should do that, which is what the picture and the source set will do. So let's just do a quick comparison test. Again, JPEG and WebP, all the same as before. We're using a kind of 1,500 by 1,000 pixel image here, which is masthead kind of size that you might see on lots of websites at the moment. And we start off with the 3 megabit PNG. And again, it's me. I don't know any other images I can use, really. So this has got a lot of detail in, so it's going to be good to kind of illustrate the quality that you can get out of it. It's me being a samurai, by the way, in Japan, so people staring. So just looking at the JPEG versus WebP, they're both output at 70% quality, just as a baseline test. For a 1x ratio image, so that's outputting at 1,500 by 1,000. We start off with 674K for the JPEG or 298K for the WebP. So again, there's massive saving between the two, but we're just going to compare that versus the double size image here. So that will be 3,000 by 2,000. So you can see that the file size jumps up quite massively. We go from 674K to almost 2 megabytes, 1.9 meg, and 702K for the WebP. And if you really output a 3x pixel ratio image, I mean, why? I don't know. We go up to 3.3 meg nearly and 1.1. I would say that nobody, I would hope nobody is outputting a 3 times pixel density image. Is anybody? No? No one's going to admit to it, so I won't put you under the spot. I would go so far as to say that you don't even need to be outputting a 2 times size image. We know that if you scale up a 1 times image to double its size, you're going to lose a lot of quality and it will just look awful on a screen. If you've ever been to the BBC News website before they've implemented their JavaScript image fix, you'll see the blurry images that you get to it. So if we get rid of the 3 times and the 2 times, it kind of leaves us somewhere in the middle, which is what I would suggest that you do. I would say you have a 1.5 times sized image. So don't specify a pixel density in your descriptor of 1.5 times, because that won't work. Still specify it as 2 times, but just enlarge the image by 1.5 times of the size of the space that it's going to fill. Okay, does that make sense? Yeah, good. And what you'll find there is that compared to the double-sized image, you get a reduction of about 30% in terms of the file size. So it's a massive file size saving that you can get. And I don't think that there's that much of a difference in terms of quality. So I'm just going to go to this here. So just look at the wrinkles, you can see the quality. So here we have the 2 times image. I'm hoping this screen can kind of illustrate the quality. And if we drop down to 1.5 times, I don't think you can see much, if any, difference in quality at all. So you can try taking it down further if you like, or depending on the images, you might need to scale it up a bit. It's all a trial and error thing for the images that you've got. But I found that 1.5 times works really well and delivers quite a large saving in terms of the file size. Right, so let's go back. So just to compare all the different options here, we've got the 70% size here. We're going to go with a 1.5 times. What I would also suggest you try as well is taking the quality of the image down. Because the browser kind of does the scaling for you, you can drop the quality a lot further than you might think. Because of the way that the browser downsamples the image, because it's larger than the space it needs to be, a lot of the quality and the artifacts can actually be kind of downsampled out of the image. So if I just go back to this. So this is a 0% quality JPEG. And this is a 10% quality WEBP, which is about the same. But it's a massively smaller file size. But in terms of the, when you view it kind of not scaled, on this screen anyway, it's not great. That's where it all goes wrong. You don't see the kind of pixelation that you do on this giant monitor here. All the images are in the slides with the presentation, so you can have a look and compare between them to just see what would work for you. But in terms of the comparison between the file size here, if you go for a 1.5 times WebP, you can take a 1.25 megabyte JPEG at 70% down to almost 181K. So it's a huge amount of savings that you can get. I mean, even if you did it with a JPEG, you can take it down to 250K. So it's something you should definitely try with the images that you've got, just to see how far you can kind of take it before it breaks. And that's the kind of thing that I've been doing, is just playing around to see what file size I can get down to. And if you want to see a live example of this, Amnesty International, the global site, not the UK one, has 1.5 times images. I think we use a quality about 30 or 40% on JPEGs. So that's a live example of it working, and as far as I know, there's been no complaints about image quality on there, but it's just bringing it down as far as you can get away with, essentially, before people notice. So, be lazy. That's my next message. Lazy loading is a great way to display images and save on performance. If you've got a JS solution at the moment that you need to use, that's fine. But native lazy loading is coming to HTML. So it's the loading attribute on image tags. So you put it on the image tag, either on its own or within the picture element. And it's loading equals lazy. You can also have loading equals eager, which tells the browser to load it as soon as possible, or loading auto, which is just default. It's like it's not there. So at the moment, the support is abysmal, but it's coming, you know? So a browser, a JS fallback definitely, or polyfill for the minute, but it's definitely something to watch out for. And by adding it to it, you don't lose anything because it will just be there and ready to work as soon as it gets implemented by the different browsers. For some reason, they were really up there with it, so I don't know why. Well, I got these literally just a few days ago, so it might be. These are current stable uses, so it might be in Canary. I'm not sure. I've not checked that one. So serve them right. So you can also improve download performance by using a CDN. I know there's a few CDNs here tonight. No one is better than the other. If you are not using a CDN, then try and cache your images as aggressively as possible. If it's not something you're comfortable with, talk to your friendly DevOps team. And that's it, just to go through an overview. So make sure you're tailoring your images for as many people as possible. So pixel density, the right size, and the right format as well, if you can do. And test and compare and see what works for you. Different images are going to compress differently depending on which settings you use and how they look. An image of a sky is going to get a lot more compression and artifacts in it than something with a lot of detail. So just see which one works for you. And lazy load wherever you can. And then just serve them as efficiently as possible as well. Thank you.
Cool. Thank you, Darren. I think that was your first talk, wasn't it?
That was, yeah, that's my first big talk.
Very first talk.
Yeah.
So, you know, give him a second round of applause. So, do we have any questions on?
Oh, God.
We'll start with Matt and we'll work backwards.
Excellent first talk, really good.
Thank you.
Any tips for automatically generating those images rather than doing it manually?
So yeah, so I've used a manual just in there just to do it myself. For the example for Amnesty, that's all done automatically. So we just use I can't remember, it's a .NET project, so it uses whatever image compression function we have on that. But again, when it's an automated thing and you're not sure what images are going into it, it's best just to test and kind of find the happy medium. If you're curating the images yourself for a very bespoke site, then obviously you can play around a lot more and get them perfect. But yeah, we just chose one that was kind of the best option that you can use, really.
I can just see content people just uploading a massive image and you just need it to do it automatically.
Yeah.
It's trying to get that balance.
Yeah, so the again, Amnesty is content managed. So we resize it down to the 1.5 times the size of the placement that it's in, and then it's scaled down the quality as well, down to I think 30 or 40, I can't remember.
Hello. Hi. Lazy loading and the customer experience. What's your experience with that? What do you know of customers and how they perceive it, especially on like slower network speeds?
So it depends obviously on the length of your page essentially. I mean, there's no point lazy loading an image at the top of the page for a masthead, but if you've got, you know, images all the way through a long article or something like that, then I think it definitely, for me, it makes sense to do it as long as you've got kind of the placeholder there. To show that either an image is coming or you don't want, personally, I don't want the jarring experience of something bumping the content down halfway as I'm reading it if it's not loaded in. quickly. But it's again, it's see how you feel about it, and I think I would prefer that than loading a load of images when people never get down to them.
Hi, thanks for your talk.
Thanks.
With the native lazy loading, do you by any chance know if it will stop the layout shift natively?
So I think this is one of the things that's probably preventing it coming in quicker than it is. I know Google's doing a lot of work into that, into stopping the kind of the layout changes. So yeah, I think that's probably something that the browser vendors are looking at in terms of bringing it in. I've not actually looked at native lazy loading in IE. I don't think they're going to have handled that, but yeah, I know that Google's definitely looking at it, but I'm not sure about other browser vendors.
Thank you.
I think Gideon has something to add, actually.
Yeah, great talk. Like the unicorn as well. I don't know. Have you had experience with Intersection Observer? Use that?
I've not used that
to load images when things go into viewport.
Oh, in terms of
used it myself,
right. So I've used JavaScript kind of lazy loading before, and kind of played with how far from the the end of the screen they should load. But again, that's just kind of trial and error to see what feels right based on the size of the image. If you've got a large image, then it's probably best to give it kind of a larger kind of space before it starts loading in. Whereas kind of you've got smaller images, they can be loaded in quite quickly. Well, I would assume that small images load quickly anyway.
Cool. Thanks.
Settle in.
So yeah, I've got a question about progressive JPEGs, because they're a thing.
Yes.
And you can in theory get some kind of image quite early.
Yep.
Does WebP have the same kind of thing?
I'm not exactly sure, to be honest, because I've been focusing all on the. I don't know. I think I died with the JPEG then, apparently. I think because of the file size is really small, and the way that kind of images are loaded now anyway, in terms of just choosing the smaller ones and going up from that, I don't think they've done it. But what I have done before is done the kind of the very, like, the 4 or 5 pixel image as a base 64 encoded placeholder, sometimes just to, a medium-esque style loading. But no, with the kind of file sizes you can get down to, especially on smaller images, kind of 400 or 500 pixels wide, you can get them down to kind of 20 or less K than that. So I'm a big fan of WebP, so that's my solution.
Hi, great talk. Particularly like the choice of images. I've been kind of looking at the spec for quite a while, and there's network information where you can get the download speed. I'm quite kind of excited of what the application could be. I don't know if anyone of you or anyone else has kind of looked into it. I think it's in one of the very new Chrome versions.
Yeah, I mean, this is the thing with kind of the image tag enhancement with source set and sizes, is that the browser does a lot of the thinking for you on that. So, I mean, it's conceivable that it could look at that kind of information as well, which is certainly, I think, where it's heading towards. But I know that you could start looking at that yourself with JavaScript and stuff as well.
Because I guess you could have the situation where I might be on a Retina screen, but I might be tethered somewhere on 3G.
Exactly, which is another thing about kind of delivering super high resolution images to people just because they've got a Retina image. I mean, it's a nightmare. Well, I find it a nightmare on my phone anyway, especially on a train coming down to wonderful London.
So what about offline? If you have a service worker and you're trying to build a progressive web app that works offline, do you have a different image strategy for the images you save offline to the ones that you would serve if the user were online?
So in an offline, I've not really done much testing with the offline kind of progressive image enhancement options in terms of picture and source, because I know that you can specify which files get saved down to the browser. So I would say in that case, maybe save the lower quality ones, or even just the fallback image, depending on your use case. I mean, if images are vitally important to your offline app to illustrate something, or if they're doing things like maps or things like that, then yes, save the highest quality one that you need. But if you can get away with offline use, just saving kind of the smaller ones, that is probably something that I would look at doing. But again, it's all based on your use case, I guess, and how important the image is to what you're showing the user.
Yeah, I mean, I wondered whether for one user on one browser, it would be common for them to, be in like a small image need, and then suddenly like have a large image need, like they've plugged in an external display or something, and now we need to give them big images where we needed to give them small images before.
Yeah, I mean, yeah, it's conceivable that could happen, definitely. So I guess it's just a case of deciding when you're setting up your manifest how many images you want the users to have to download. But yeah, I kind of start with the minimum and then go from there, I guess. And if they resize the screen and get a blurry image offline, sorry, or
fail well.
Any more for any more? Have we exhausted Darren with questions?
I thought he had another question.
he was always going to ask you the hard one anyway. All right, so thank you to Katie for a great talk on load testing, and to Darren for a great talk on images. That's what it's about. We'll take the videos and we'll upload them later in the week, so they'll be there for you when you want to review it. We're going to do some tidying up in here. Then we're going to go to the pub over the road. The Seahorse? Yes, it's the Seahorse. If you want to take whatever's left, feel free, because otherwise it's just going in an FT fridge for them to drink it. But so if you want some nice lemonade or some non-alcoholic beer or even some alcoholic beer, feel free to take it with you. But thank you very much for coming, and we'll see you all next month.